what is it, 93. Close out one of these things here. And if I'm not mistaken, the first day I asked that you guys kind of go through generic setups. Intercepts, x-intercepts, vertical asymptotes, horizontal asymptotes, and if necessary, a slant asymptote. Once you get those 4 parts going through, everything else kind of falls into place about what comes next. It's a matter of selecting values. So in the first few setup ones, what you want to look at? I know, of course, you were saying something in the hallway a second ago. Was there any of those specifically you want to look at? Do you remember? We're all just staring at you, trying to figure out. No pressure, none whatsoever. Anybody from those then? That first group, come on. What do you got? Sure. All right. So on 13, if we go through it, and we go through the process of the way we were describing it the other day, go through each step individually. If you always start these problems by first identifying your x-intercepts. Your x-intercepts for all of these rational expressions will always be located at the zeros of the numerator, which means I need to factor my numerator. So when I go to factor my numerator, I ask what times what is -10. Then I add together to get -9. -10 and 1, good. So that's going to give me a 2x squared minus 10x plus 1x minus 5. Just put it off to the side there. And that's setting me for a factor via grouping. Right? GCF, I'm going to get a 2x. I get an x minus 5 plus 1 and an x minus 5. That allocates my zeros then to being at -1/2 and 5. Hey, bueno, it's me to 4 factor. Tu tengas un cero uno negativo uno over doso. I don't know how to say 1/2. Overo. I just make it up words sometimes. All right, so there's that. It's the accent that I generated just sells it. Yes, next thing I would do is go for my vertical asymptotes. Vertical asymptotes always occur at the zeros of the denominator. This one's a really nice and easy one to be able to factor the denominator. What are your zeros at x squared minus 16? Yeah, plus or minus -4. So second thing we do is our vertical asymptotes will be at x equals plus or minus 4. One of the things that I did like on that sheet that I gave you yesterday, I don't know if you recognize it, but it said try to find the y-intercept. Because what is always the value of x for your y-intercept? 0. And this is a great idea. If you know where your y-intercept is, it kind of gives you some sort of scale where things are crossing the x-axis. So in this case, if I get my y-intercept, it's going to give me 5/16. Okay with that? If I put 0 in for x, I'm going to get 5/16. So I know I have a y-intercept at 5/16. So here I'm going to start plotting stuff. Oh, forgot. Horizontal asymptote. Now the horizontal asymptote was the one. Yes, ma'am. Your y-intercept is whenever your value of x is equal to 0. So if I substitute in 0 for x, I'm going to get my y value. Okay. When I do my horizontal asymptote, that's when you have to go back to those 3 different categories. You either had degree bigger than the numerator, smaller than the numerator, or equal. Yes, sir. I'm going through the whole process to make sure you get everything. Okay. So in this case, my horizontal asymptote since the two equations have the same degree, that follows the same rule that we did on Monday in section 9.2. In section 9.2, when we had linear equation divided by linear equation, we always looked at their leading term coefficients. Remember that? Same deal. So I'm going to have y equals 2 for the horizontal asymptote. Now I have a bunch of junk to plot. X-intercepts at 5 and a half, negative half. Vertical asymptotes at 4 and negative 4. And I knew I had a y-intercept at 5/16. 5/16 is a smidge less than half. 8/16 would be half, wouldn't it? That's that mark. Okay. Now remember, at this point then, it was a matter of trying to figure out where specific values are occurring. This is when you would just pick points. Now, in this first grouping, this is all you had to do. Okay? In the first grouping, it was just identify where everything goes. What you did yesterday is you took it a step further. Yesterday, you would plot where everything, all the junk winds up going, and then you would pick a couple of points within here, a couple of points out here, and a couple of points out here. That way you can tell what direction the curves are moving themselves. That's where things get, I don't want to say messy, but they get, you just have to be careful when you do your substitutions. Okay? So from Monday, you were done. Yesterday, you would go further. What did you want to look at from yesterday? Yes, ma'am. 32. Yeah. So, what's that? From yesterday, yes. You had to plot your points and all that. If you listed it, that's fine, but I was hoping, I don't know if you might have heard me, I was saying you're going to be better off if you start plotting it, because then you start to learn about proximities of what values you're going to start choosing. If you didn't do it, it's not the end of the world, but because it was practice to get you to yesterday. Yeah. We're going to be like 3 different curves? Yeah, there should be. Sometimes you'll see them with the certain numbers and all that too. Yes, sir. Yeah, the slide has to put. You should have. Let me snap this one in real quick, and I'll come back to that after I get this one done. Okay. No, I think it's 16. You said 33. 32. Okay. Let me go through 30. Let me go through 32 real quick, and then I'll come back to that one. All right, Rory. All right. Well, this one's fun. Okay, so this one, when you get to this one, you have to get your zeros of the numerator, and that means you have to set the numerator equal to 0. Now, this one is asking you to solve for x. Well, if you work backwards, I'm kind of hoping that you guys would have figured out you would have done x cubed is going to equal negative 1/3, right? Which means you take the, how do you undo a cubing? You do the cube root, it's going to give you a crummy decimal. And that's fine, because what happens here is that if you take, what this is asking you are, what are 3 numbers that you multiply together to give you a negative? You can have 3 negatives together, because negative times a negative is positive, times a negative is a negative. So you can take odd roots of negative numbers. It's going to be okay. It just happens to give you a real crappy decimal. So the crappy decimal was? It was about 0.6, negative. Yeah, so you get x is going to be at negative 0.69. And that's fine. For right now, it's just an approximation. Yes, ma'am? No, because it's an odd. And then you kind of go through the same thing with, what is that, for the denominator. The denominator would have been pretty easy. It was 2, wasn't it? Yeah. So here's your x-intercept. Your vertical asymptote was every okay with me just saying it's 2. Add 32 divided by 4. What are three numbers you multiply together to get 8? 2. And now you would have a horizontal asymptote where? Very good. Where's your y-intercept? So it's some really awesome numbers for this problem. Here's 1, so here's negative 0.69-ish. 3/4. 3/4. Sorry, what was that? So that would make way up there. What are we at vertical asymptote at 2? Is it doing something like this if you graphed it?
Yeah.
Which means there's something, there should be something over here then?
Yeah.
That's kind of what you're doing, okay? At this point here, then you would just basically, I would pick 1, I would pick -1, maybe -2, and then I would pick 3 and 4 in column. And just substitute it. All right? Yes, ma'am. The x-intercept is telling you where it's crossing the x-axis. The y-intercept tells you where it crosses the y-axis. The asymptotes tell you where things are what we call bounding towards. Where they're approaching specific values but not quite getting there. So it allows you to tell the shape of the curve. Think of it this way. Remember we did conics. We did hyperbolas and conics. They were left and right or up and down. Remember we'd hug the asymptote, go through the vertex? It's the same idea. Okay. Yes, sir. Yes, it is. That is where, it's more of a pre-calc thing of why that happens. What happens sometimes is you could get what's called a discontinuity, because sometimes when you have rational expressions, when you factor things, let's say you have this. Let's say you factored something out like that. It tells you had x-intercepts at 1, -2, vertical asymptotes at -2 and 5. Well, when they simplify out, even though there's that asymptote there at -2, there's a hole in it that it crosses through. It's a total pre-calc thing, but you will see, you probably saw that on a couple of the problems from last night that things jump through. It's fine. I'm not going to have you guys do any formal assessment that has anything like that, but it is something that does occur that does come up in pre-calc. When we get through the rest of the graph, and I think once we finish this out, probably by tomorrow, I'll bring that back up because I think there's maybe one problem that you might ever see in the Alpha 2 book, but I did write down a couple from the pre-calc that shows that because people always ask because there's that one. It was in that first section from Tuesday that had that, wasn't it? But yeah, that does happen. What was the one you were talking about, Robert? Was it 19? Okay. What else do you guys want to look at? Yes, sir. Sure. Okay.